Hey guys, welcome back. Just want to do another video with you. Today we're going to be building a much bigger battery pack. It's not quite the 1000 watt hour pack that I was intending to do, but I have an immediate need for something right now, which is a trolling motor battery that lasts a little bit longer. So I'm going to be building that first, and I'm going to try to take you guys on that journey of how we go about building that. Okay. So what we have here is a battery pack with NCR 18650Bs, same as the last project. We're going to have 24 of them in parallel and 3 of them in series. And that's going to give us about 81.6 amp hours for the whole pack, which is about 905 watt hours. Okay, and that's 72 individual NCR 18650B cells. We're also going to be using these nickel strips. Can't remember where I got them, but I'll post the link in the description of the video. But these nickel strips have built-in fuses already, so that's going to save us a tremendous amount of time in individually fusing these. It's going to make the pack look a lot nicer, cleaner, and it'll be safe, right? So what we're going to do with this once it's done is we're going to throw it into this box. It's from Flambeau Cases, same places where I got the other case. We're going to have a master switch here, probably put a couple USB things on there, maybe a power display there. We'll have some big fat battery terminals here, and I was thinking some waterproof connectors there. So we'll make 2 of them so I can put this in parallel with my previous pack that I built, while also having another one that's going to be fully regulated at 13.8 volts and a max of 28 amps for that port. And everything should fit nice and snugly in here. I'll show you the parts of everything we're going to be using, but for now we'll do a time lapse of building this pack for the majority of the part, because I really don't like video editing. I'll do a bit of it in real time, and then the rest you can follow along in time-lapse video. Okay guys, so we're going to start off by just gluing this down. They don't really have to be glued, because once they're you weld the tabs in place, it should be held, but I don't want stress on the actual fuses. So we're going to put a strip of glue on there just to hold it down securely, and then we'll go ahead and weld this in place. We'll try to do this quickly. Alright, so that's good enough for what we need. So then now I'm going to go ahead and start welding. I've never welded with these nickel strips before, so I'm not sure how much power to use. But we're just going to go ahead and figure that out on the fly. So I'm starting off at 20 milliseconds, and this is the Molectrix spot weld. So we'll do 4 welds per cell, but we'll start off with 2. Okay. So immediately you see that spark there, right? So that tells me this is not pure nickel. If this was pure nickel, you would not see this. So this is a mix of nickel and, or it's probably steel coated in nickel. Probably not the best material, but anyway, it's saves us a lot of time with doing the spot welding.
Be careful.
So as you can see, this certainly saves a ton of time. I got 1 strip done in no time at all. Okay, you know what? Actually, I should be using my safety glasses because there are sparks flying all over the place. Please step away. I think I'm gonna increase to 30. So we'll try 30 milliseconds and see what that does. Again, I'm gonna come back and do another round of welds. Seems a little bit better. And actually, one thing I wanted to show you guys, in case you do have this thing, I'm using these lithium ion LiPo battery packs, and I actually put 2 of them in parallel, just to give us a little bit more current for the spot welder. These will, this is a 50C pack, but it'll handle a burst of 100C. And with 2 of them in parallel, that should give us about 200C. Okay. You guys give me a second. I have little ones running around here. Say hi.
Hi.
All right.
Hi.
Head on out. Come on. Okay, guys, so we got the nickel fused strips soldered or welded in place there. There's 4 welds per cell, and now the next thing that we have to do is create the series connection. So actually, if I were thinking ahead of time, I would have ordered the 6P nickel strip that would have created the parallel connections as well as the series connections. But I didn't do that ahead of time. I wasn't really thinking. So we'll use what we have. I cut a bunch of these brass strips. I was going to use that for the series connection, but then I realized I did have the nickel strip, so that will allow me to do everything without having to solder. So I can just spot weld these in place, if I use the strip, basically I would have to solder that. So that would take a lot more time, create a lot more fumes, and I don't really want to mess this up with a bunch of solder. So you can't really spot weld these without a huge amount of current. Okay, so we'll create the series connections that way. The spec sheets on these things, I mean, they don't really specify how much current you can carry on this, but I think the general consensus is that about 10 amps continuous is what you can carry between this nickel strip. About 15 amps it starts to get hot, and we don't want to do that. So I will definitely probably double this up, because I want to ask about a maximum of 100 amps out of this battery. For the most part, for its intended purpose, it's going to be carrying about 30 amps maximum for the trolling motor. But for other applications, when I hook this up to like an inverter, like a 1200 watt inverter, I want to be able to deliver about 100 amps maximum, and the main fuse is going to be about 100 amps, right? So we need to build the battery to be able to deliver that much current, and so 10 amps per strip there's going to be about 7 of them. That's going to give me 70 amps, so we're going to be short. So I'll probably double up on that, and that'll give us more than enough current carrying capacity across the series connection. Okay, so we'll do that in time lapse, and then we'll be back when we're done with that. Okay guys, one more thing I just wanted to mention, just the important safety tip, okay? So one thing you probably noticed is I had my watch on at the beginning of the build video. I'm taking it off now, and I'm also going to take off my ring, because now that we're creating the series connections, this is going to be a live battery. We're going to have actual, once we're done, it's going to be live, right? So it's quite possible that accidentally with my wrist or with my finger, with the ring, I could short out a connection between this, and this battery is going to be able to carry several hundred amps, right? Which could cause a lot of major problems. So just a safety tip, make sure that you are, it would probably be even better to wear gloves, but I mean, this is very low voltage, it's not a problem, you can touch it with your hands, but make sure that you don't have any metal on you, no watches, no rings, nothing like that before you get started, okay? Just wanted to mention that, and we'll move on with the rest of the video. Okay guys, so now we have a electrically finished pack. So I'm just going to double up on that. You don't need to see that right now, but before I do that, I just want to verify that we have our connections made properly. And so right now I should be able to measure the full pack voltage. So keep in mind, these are not fully charged cells, so we should probably get anywhere between 11 and 12 volts. Okay, so this is the negative side, and this is the positive side. Sorry. So I should be able to put one probe here. Okay, and should be able to see, there we go. So we got 11.27 volts across the whole pack. So we know everything's electrically connected, that the battery is technically now done. So now we're just going to go ahead and reinforce these, double them up, and then we'll put on our balance leads, and we'll go ahead and shrink wrap that, and this battery will be complete. So let's do that now. Hey guys, okay, so we're back. The pack is now done. I went ahead and put in the balance lead. So one, put it there so you can see it. So there's one external balance lead that I can use to check the balance of the cells. I have the balance lead that is going to go to the BMS, and I have the power plug here. So I'll just show you what I went ahead and did for soldering these wires. I basically, it's a large gauge wire, so I split it up and I doubled up, or actually I tripled up on the end pieces. So the positive and the negative side, there's about 3 strips here to handle the currents, the large current flow that's going to go through there. Same thing on the other side. And then I just split up the wire there so that it's a little bit easier to solder, and it also disperses the current a little bit so that it's not all coming from one central point. You could see the cells that right now they're actually well balanced. And this is the BMS that I'm going to be using here. It's what's the brand? It's a Dale branded Dale or Dale, I'm not sure. Branded BMS. It's 120 amps, and this will provide overcurrent protection, under discharge, overcharge, and balancing of the cells. So that's very important for this. So really the only thing left to do now is to just shrink wrap this, and we'll be done with the pack, and then we'll be back for the next part of the video, which is the building of the actual box. Okay, so let's get this in the shrink wrap. We can do that. And hopefully this shrink wrap is the right size. It looks kind of big, but hopefully it shrinks down to a nice tight fit. Okay, so place that somewhat in the middle, and looks good there. Okay, everyone is sleeping. If you're wondering why there's bags under my eyes, it's because my daughter constantly wakes me up, but also the only time I have to do these projects is really early in the morning or really late at night. So I started the video really early in the morning, and right now it's really late at night. Everybody's sleeping, and hopefully I don't wake anybody up with the hair dryer, but we'll see. Okay. All right. Okay, so that's done. Just gonna let this cool and try to clean up these edges, and that'll be it for the pack. Okay guys, so that is the pack. It's all completed, it's all cleaned up. Corners, everything are nice and cleaned, somewhat sealed. Not that it needs to be waterproof or anything like that, but just in case. Now here's the box that it's going to go into. And let's throw it in there. Okay. So everything fits in there nicely. And yeah, next step will be to get everything built in this box. Add some accessories, and we'll go from there.